In this video, I'm going to be talking to you about uncertainty and error. When we make measurements using a measuring device like a ruler to measure, for example, the length of a line, let's say I have a line here which has a length of, well, an unknown length, and I want to find that length. I can use my ruler to measure that line. In this case, the line looks like it's about 5 centimeters. I line the one end of my ruler up, and I can see the line goes to almost the 5 centimeter mark. It's maybe slightly before the 5 centimeter mark. I'm going to say it's about 4.8 centimeters, about 4/5 of the way between the 4 and the 5 centimeter mark, and I line that up with the edge of my ruler. But how accurate is the measurement that I've just made? 4.8 centimeters. And how precise is it? That's what we're going to be talking about today. Accuracy refers to how little systematic errors affect the measurement. Whereas precision refers to how little random errors affect the measurement. So in the case of my ruler here, you can see the ruler is quite thick. What that means is, depending on what angle I look at the measurement from, I might get something like 5 centimeters, I could get 5.5 centimeters, or if I lay the ruler down flat, I could get something less than 5 centimeters, say 4.8 centimeters. Right? These would be errors that we refer to as systematic errors, because they would affect the measurement always in the same way. For example, if I was holding my ruler at an angle, all of the measurements would seem slightly longer, than what they should be. Whereas if I was holding it flat, or looking at it, not lining it up, for example, with the start, all of the measurements would be slightly shorter than what they should be. So that would be affecting the accuracy of the measurement. The precision of the measurement, in this case, is fairly fixed. There's not too many random errors that I could be making in terms of the measurement of the length of this line. We need to have a way of expressing the uncertainty in the measurement that we've taken. Uncertainty in measured values is always given as half the smallest division on the ruler, or measuring device. So in this case, each of these divisions is 1 centimeter. So the uncertainty in my measurement, 4.8 centimeters, I could express as plus or minus half the smallest division on my measuring device, in this case a ruler. So the uncertainty in a measured value is half the smallest division on the measuring device. Okay, in this case it's a ruler. The next thing we're going to talk about is how uncertainty in measured values propagates through calculations. For example, if I wanted to measure the perimeter of a rectangle, let's say a rectangle that looks like this, I'd take 4 measurements. I'd say this side is 5 centimeters. This side also looks like 5 centimeters. And the shorter sides appear to be 2 centimeters. And this side we'll say is also 2 centimeters. Now we know that the perimeter of a shape is equal to the sum of the sides. Okay, in this case that's going to be 5 plus 2 plus 5 plus 2, which will be 14 centimeters. But how much can we trust this measurement, 14 centimeters? What we need to do is understand how certain we are of each of the measurements that make up the 14 centimeters. In this case, we've got 5 centimeters plus or minus half a centimeter, plus 2 centimeters plus or minus half a centimeter, plus 5 centimeters plus or minus half a centimeter, plus another 2 centimeters plus or minus half a centimeter. So what we do is we're going to add the absolute uncertainty in each of the values. So the uncertainty will be plus or minus 0.5 centimeters times 4. So that will be plus or minus 2.0 centimeters. So we'd state our measurement 14 plus or minus 2.0 plus or minus, let's just say 14 plus or minus 2 centimeters. So for addition, the absolute uncertainty adds. This also holds for subtraction. We add the absolute uncertainty. Uncertainty can also be expressed as a percentage of the original value, and we call this percentage uncertainty. Percentage uncertainty is given as the absolute uncertainty divided by the measured value. Times 100%. So for example, the percentage uncertainty in our perimeter measurement would be given by the absolute uncertainty, that's the plus or minus 2 centimeters, divided by the measured value, times 100%. So what we'd get, when we pop that in our calculator, is 14.29%. The reason percentage uncertainty is a useful value is that while for addition and subtraction the absolute uncertainty adds, when we're dealing with multiplication and division of uncertainties, what we need to do is add the percentage uncertainties of the value. So if we go back to our shape, which we said was 5 centimeters by 2 centimeters, if we wanted to find the area of that shape, we'd multiply the length and the width. So in this case, the length measurement would be 5 centimeters, the width would be 2, and we'd end up with an area of 10 square centimeters. But how could we express the uncertainty in this calculated value? Well, for multiplication and division, we're going to add percentage uncertainty. So what we need to do is actually calculate the percentage uncertainty in each of our measured values, the 5 centimeters and the 2 centimeters. So 5 centimeters plus or minus a half a centimeter as a percentage uncertainty would be expressed as 10%, and 2 centimeters plus or minus a half a centimeter would be expressed as 25%. So when we add our percentage uncertainties, the sum of the percentage uncertainties in our original calculation, so that's the percentage uncertainty of the length and the percentage uncertainty of the width, what we'll get will be 10% plus 25%, which is 35%. So we can express our calculated value for the uncertainty in the area. The measured area, or the calculated area, would be equal to 10 centimeters squared, or square centimeters, plus or minus 35%. We can now, to make a little bit more sense of this value, we can now convert that percentage uncertainty back to an absolute value in relation to the calculated value. So 35% of 10 centimeters would actually be 3.5. square centimeters. And that's the propagation of errors, uncertainty, and precision and accuracy.